is just match up each expression with the rule that applies to it. So number 1, what rule is that? Not equals 1. Turn it into a fraction. What kind of exponent is this? It's a negative exponent. When we have negative exponents, we've got to change the place of the base and change the sign. So it kind of turns into a fraction. So what does x to the negative third power, what does that simplify to? How do I write that with a positive exponent? Yeah. 1 over x cubed. Okay. And then what if I had 1 over x to the negative third? What would that become? Yeah, just x to the third. So it switches the base from numerator to denominator, or denominator to numerator, and change the sign from negative to positive, right? Our final answers should never have negative exponents. We should always write everything with positive exponents. How about number 2? What rule is that? Anything raised to the 0 power is what? 1, right? But what about this? Does that equal 1? I had people who I think just saw 0 as an exponent and then said the whole thing equals 1. No, just this equals 1. Just that equals 1. And then that x squared over x cubed, we'd have to simplify that, okay? What about for number 3? What rule is this? Huh? Yeah, D, add the exponents, right? Because even though I don't have an operator between these two terms, what is the operation in between them? So that's v to the 4th times v cubed. When I multiply with exponents, I add the exponent. So how does this simplify? What is this? V to the 4th times v cubed. V to the 7th. Good. Add the exponents. Okay, so number 4, we just have a and b left. Which one is it? Yeah, b. When I raise a power to a power, I multiply my exponents. B to the 6th, right? 2 times 3 is 6. And then lastly, number 5, what am I doing? So what does this become? But don't the x's like cancel out or something? No, base stays the same. I was trying to trick you. All right, so it's just x to the 4 minus 2 is 2, so x squared. Okay, so this section is going to look just like this tomorrow, just different expressions, obviously, different order. You don't have to simplify it like I did here. I was just going over that to review. You just have to give me the letter. And part of the reason why I'm doing that is to test you on whether or not you know your properties of exponents, which you all should because they're posted right there. But also to just kind of get your mind in the right place and remember everything you need to do so you can tackle this section. It seemed like a lot of people were really struggling on this yesterday, so let's just take a breather and break it down a little bit. So there's like 2 suggestions I have for you. Because when you look at these things, it's like a lot going on all at once. And it's like trying to eat a pizza by stuffing it all in your mouth at the same time. You can't do that, right? I don't think it'd be fun. You'd probably choke, right? You need to take it and break it up into little pieces and eat one bite at a time, right? So the first thing I want you to think about is we want to get rid of parentheses. Just get rid of the parentheses. So in number 6, I got parentheses down in the denominator, right? How am I going to get rid of those parentheses? Yeah, it's raising powers to a power. But what's the power of my 2? Yeah, and what's the power of the x? Also 1, right? So I'm going to rewrite this, but I'm going to get rid of the parentheses down there. So my x squared up top stays the same. And then raising a power to a power. So what do I do with my exponents? Multiply. What's 1 times 2? So I've got, whoops, 2 squared, and I have x squared. So 2 squared x squared, and then times that x cubed. And then from here, you might see some other ways to do this. There's like a whole bunch of different ways to think about this, but for right now, all I'm going to do is I'm going to split this into 2 parts, and I'm going to split it up according to the bases. How many different bases do I have in there? 2, just 2, right? I have 2, and I have x, right? So I'm going to split this up into 2 separate fractions, one that had that 2 and then one that had the x's. So I'm going to take this little chunk, and I'm going to take this little chunk. Okay, so the blue part, I've got this 2 squared, but is that 2 squared in the denominator or the numerator? Denominator. So what goes above it in the numerator? Yeah, and 1 just kind of acts as a placeholder there. And then I have x squared over x squared times x cubed. Okay. The blue part we can simplify. 1 over 2 squared. What's 2 squared? 4. So it's just 1 over 4 times, we have x squared over x squared times x cubed. What do we see in here? What could we do? Yeah, let's do that. So I've got x squared in the numerator, and then I have x squared times x cubed. I'm going to add my exponent since I'm multiplying, so x to the 5th. Okay. My 1/4 over here, I can't really simplify that. That just stays as it is. But then what do I do to simplify this? What do I do when I'm dividing with exponents? Subtract. So 2 minus 5 is -3. Good. So we're closer. But I said no final answer should have a negative exponent. So how do I write that x to the -3rd with a positive exponent? So that's 1 over x cubed. And my blue part is still the same, 1 over 4. Now, this 1/4 times x to the -3rd, that would be like half credit. It would give you. This I would give you full credit on, but there's like a more grammatically correct way of writing this. Right? I just have 2 fractions. What do I do when I'm multiplying 2 fractions? That's dividing. Multiplying, I just go straight across the top, straight across the bottom. What's 1 times 1? And then 4 times x cubed? 4x cubed. That's it. That's my answer. Can you guys try number 7, please? Except for where is that 2? This is correct. But then maybe split it up into 2 parts and see, because you're really close. Okay. Remember, what did they say the first step should be? Get rid of our parentheses. So we're gonna, what do we do when we raise that power to a power? Power to a power. 4 times 3. 4 times 3. Man, I felt that all day and got a cough. Like just hit me. I don't want to get too much defense for that. Yeah. Yeah, perfect. Now what can you do to simplify that top part? Don't multiply. What do you do when you multiply here? Yeah. So Okay. So that would work for that x to the 8 would be up here. And then 2 stays in the denominator. So we have to change it. Oh, so you're close. I'm going to show it a little bit so you can look at the best one. But just gotta make it work. It's not doing it. This is a two times 4 again. Yeah. Where's that? You're close. Where's that 2? But is it in the numerator or the denominator? But what about the x to the 20th?
Oh, with the x to the 20th.
Miss Morris,
Okay.
I have to go. They didn't release the software. Okay. I'm recording this so you can watch it tonight before the test, okay? Good luck, Saturday. Yes. Except, I do not have a denominator.
I don't like it.
I know you wrote it on your paper. So try writing everything out according to its bases. Split it up. So I'm gonna okay. I hope today you'll like them more. So you need to simplify. We got x to the 24 there and x to the 25 there. We gotta simplify that.
Oh, okay.
So that's the way to do it. But it's not 2x to the 8. X to the 4 plus x to the 4 is 2x to the 4. X to the 4 minus x to the 4 is x to the 4. Right. So just but then there's that 2 in the denominator. It's 20, so that x to the 20th stays in the numerator. We only be if it was x to the negative 1. Does that make sense? Are you raising your hand? Yes. Yes. And then you can combine it into one term as well.
One x to the 20.
That's it. Yeah.
No. Because it would be, that would be the fraction of that.
And then you can simplify this one. Or you can multiply with x squared. Yeah.
This is so
So start with your parentheses. Just, I think the biggest piece for this and like the biggest learning lesson from this is to turn things little to reach up. Just start with what you have. So we don't make
Oh, like
I was specifically talking about it. Yeah, me too. This tone
what
right
am I
here.
gonna do?
It's like a thumb.
You could put a time.
I can't draw though. Here, I'll draw it. Maybe I'll try it. Okay, wait, yeah. You copy your picture. Okay. And then I'll draw your thumb.
Yeah. Let's do that.
Yeah. Did you divide?
Oh, yeah.
So 2 is good. And the 20th
Again,
is good.
the
It's not 2 is 20. It's close, but where's that 2?
Is that right?
In the numerator or denominator? Yeah, so it's gonna stay in the denominator. Now, simplify that part.
My thumb is wrong. Don't move it.
12.
Sure, yes.
Yeah.
Yeah, you knew that W.
I'll go down the board in just a second.
There's no W in the equation.
That just is this one.
Yeah, but
Now we can just simplify this part. X to the 12 minus multiply with exponent.
That's your
Yes. 12 plus 12.
Okay. You're choosing another finger.
Would you
Okay.
would you
Wait.
So that's this.
Okay.
So I'm going to do some more brain.
I'm gonna drop
24 minus 4 gives us 20, right? Not negative 20. If it was negative 20, it'd stick down here. Yeah. Okay. Let's look. So first part, we just want to get rid of the parentheses. So I'm raising powers to powers. X to the 4th cubed. So I need to multiply 4 times 3, which is 12. So I've got x to the 12th and x to the 12th again, right? So x to the 12th times x to the 12th over 2x to the 4th. What can I simplify from here? What do you think I can simplify? Somebody say it a little louder. Yeah, let's simplify the numerator. X to the 12th times x to the 12th. What do I do when I'm multiplying with exponents? 12 plus 12 is? So x to the 24th over 2x to the 4th. Now, oops. Now, there's other ways people have thought about it, which is fine. Can you guys put your phones away, please? But from here, what I'm going to do is I'm going to split this up into bases. Two different bases. So I've got my 2. And what is the 2 underneath? I've got 2 in the denominator. 1 over 2. And then I have x to the 24th over x to the 4th. What do I do when I divide with exponents? Subtract. What's 24 minus 4? 20. So it's x to the 20. And that's like, it's kind of like over 1, right? So now what's my final answer going to be? Yeah, x to the power of 20 over 2. Okay. Number 8 is easy. What do I do for number 8? Add them. So what does this become? 3 to the power of 6, right? Base stays the same. Base stays the same. You guys do 9. You guys do 9. So for number 9, what's my base? 2. And then what do I do with my exponents since I'm multiplying? I add them. What's 2 plus negative 3? What's negative 1 plus 0? Negative 1. So 2 to the negative 1. How do I write 2 to the negative 1? 1 over 2 to the first power, or just 1 over 2. And that's it. Okay, so number 10, this is what I'm talking about now, breaking it up into little chunks. Okay, so we've got 3 bases in number 10. What are my 3 bases?
3x and 1.
Perfect. So I have 3 over 3. I have x squared over x cubed. And I have y to the 0 over y cubed. And I'm going to take that and I'm just going to break it up into 3 little fractions. So it's really, really easy. Yeah? So I've got 3 over 3. And then I have x squared over x cubed. And y to the 0 over y cubed. Okay? Really, really simple. 3 over 3 is 1. X squared over x cubed. What do I do with my exponents there? What's 2 minus 3? So x to the negative 1. And then what do I do here with my exponents? Yeah. 0 minus 3 is? So y to the negative 3. Okay, that's half credit. But now I need you to rewrite it without negative exponents. So I can kind of drop that times 1 at the beginning, right? Because it doesn't change anything. But how do I write x to the negative 1? 1 over x. And how do I write y to the negative 3rd? 1 over y cubed. It's really not that bad. It's just, it looks nasty. Okay, so now how can I write this? This is like 2 separate terms. I wouldn't mark you off if you gave me this as your answer.
Would it be y to the 3rd over x? Be 1 over x.
Yeah. So look, so it started out, this was just y to the negative 3rd, and then it changed to 1 over y cubed. Right? 1 times 1 is 1. X times y cubed is xy cubed. We okay? Can you guys try 11, please? Try 11. Rewrite it as 3 separate little fractions. Split it up into 3 little fractions. Instead of 1 giant fraction. This one's a little weird because it's UV at the top and then VU at the bottom. So just be careful to keep your U's together and your V's together. Oh, I did that. We're doing it. Got it. That's good. There you go. Over the yes. Well, hold on. So don't combine. So these have different bases, right? So this is u to the first, v squared.
Oh, that's right. Okay.
So that's these v squared.
All right.
Does that make
So
sense?
it's just
You're
u
not
v
adding
squared.
them, but they're different bases.
Is it u v squared?
Yeah. Okay, so what's my first little fraction that I can make from this? 3 over 3 And then u to the fourth over u cubed, and then v cubed over v. Perfect. I'm multiplying all these things. So 3 over 3 is? Perfect. U to the fourth over u third. U to the third? Just u. V cubed over v. What's this invisible exponent down here? 3 minus 1? Not adding, remember, subtract when we're dividing. So what is it? V squared. So 1 times u times v squared. I'll give you full credit if you write it like this, but we can also simplify it a little bit and just write u v squared. Okay, number 12. Number 12. So same kind of idea, but now we're just multiplying instead of dividing. But we still want to break everything up by their base. You got it? Break everything up by their bases. So I have this 2 and I have this 3 here. I'm going to take those out in front. So 2 times 3. And then I have, what are my other two bases? X and y. So I'm going to take x to the 0 times x squared. And I'm just kind of gathering them together. Gathering the like parts together. And then I have my y squared times y squared. Okay, so my first little chunk is 2 times 3. Since I'm multiplying and there's exponents, do I add those two numbers together? No. I'm just multiplying two regular old numbers. 2 times 3 gives me what, Daniel? 2 times 3? 6. Okay. X to the 0 times x squared. What do I do with my exponents? Add them. What's 0 plus 2? 2, but my base stays the same, so it's just x squared. And then y squared times y squared. What do I do with my exponents? 2 plus 2 is? So y to the 4th. And that's my answer. That's it. Can you guys try 13, please? This one? So that one's a little bit different. Think about but this is like your reverse. I put the big deal on the top. These are and your buffering right for the last one. Okay, 13. I've got a few different things. So what should I pull out in front? 4 times 2. 4 times 2. And sometimes even when I have like kind of longer problems, I'll take 4 times 2 and then I'll like cross them off as I go. And that kind of helps me. And then what's another, what do I put next? Yeah, times y to the negative 1. And where's y's little friend? What goes with the y to the negative 1? Y cubed. And then last, I've got x cubed. Okay. What's 4 times 2? 8. And then what do I do with my y's? What's negative 1 plus 3? Huh? And then do I have to do anything to that x cubed? Nope. Stays as it is. And you could also write that as 8x cubed y squared as well if you wanted to. Either way is fine. Technically, like, you should put it in alphabetical order, but I wouldn't mark you off on that. Okay. 14 is easy. What is 14? Yeah. It's 1, right? Just like 2 over 2 or 3 over 3 or x over x. If you have the same thing in the numerator and the denominator, it's going to be 1. But you can also think about it like division, right? What do I do when I'm dividing with exponents? Subtract. Negative 3 minus negative 3 is just like, what happens when I subtract a negative? So it's like negative 3 plus 3, which is 0. 4 to the 0 would be 1, right? How about 15? 15, try 15. What do you do for 15?
There's an invisible power of 1 on the numerator.
Yeah, right. 2 to the 1 minus negative 4, which is just like 2 to the 1 plus 4. 1 plus 4 is 5. So be careful on the negatives there. Okay. All right, let's flip over to the other side. I'll leave this up for another second. Okay, other side. All right. So our friend Anne is going bungee jumping. Has anybody ever been bungee jumping? Nobody? I've had 3 or 4 people. You have? Yeah? Where did you go bungee jumping? Cool. Yeah, you're like the 5th person today. But when you go bungee jumping, right, you jump and then it like the rope stretches and then you rebound, right? But you don't rebound all the way to the top, right? You rebound part of the way and then you fall back down again and then you rebound and then you fall back down, and right? You know what I'm talking about?
I've never been like on a rope, but I don't know how, it's like a trampoline, like, yeah, like big harnesses.
Yeah. So it's a little bit different,
Yeah.
yes. But anyway, so what it's saying is she goes bungee jumping and the rope initially stretches 120 feet, but every time she rebounds, the stretch is 60% of the previous rebound. Okay, so how far is it going to stretch after the 12th rebound? So let's just think for a second. The rebound amount, the rope stretch, is going to be 60% of the previous. So if the previous was 120, it's just 60% of 120. How do I find 60% of 120? How'd you get there?
Well, I used the decimal and then multiplied 12 by 6.
Perfect, right? 60% is a decimal, is just 0.60. Of always means times 120, which gives us 72. So then how would I find 60% of 72? Do the same thing, right? 0.60 times 72, which gives us, what is it?
72 times 6 is also 40%.
Yeah. Yeah. Why? What is it though? 0.6 times 72. 43.2. Do you guys want to do this 12 times until you get to the answer?
Yeah.
I don't. I want to use my equation. What's my exponential equation?
Y equals 0.6.
Give me the like template.
Template of y a to the x power times b.
A times b to the x power, yeah. What does A tell us? Starting amount. And what does B tell us? What's B? It says it over there. Common ratio. Right? What am I multiplying by to go from term to term? That's my common ratio. That's my B. So in this example, what is A? 120. What's B? 60%, 0.6. And then what do you think I'm going to use for X? Yeah, 12, my 12th rebound. Okay, so my equation becomes y equals 120 times 0.6 to the 12th power. And then I take my calculator and I practice my exponents now, so you don't come and ask me how to put exponents in my calculator tomorrow, because I've told you a bunch of times, right? I do 120, oops, not 110, 120. And then I can just do parenthesis 0.60, and then this little caret symbol to put in my exponent, and then I put in 12. So I get 0.26. So by the 12th rebound, she's not going very far, right? She's just like barely moving at the end, because that's 0.26 feet, like 3 inches. Okay, so tomorrow you're going to have a problem that's really similar to this, except instead of a bungee jumper, it's going to be like a bouncy ball. So I was going to do like an experiment like you yesterday, but then I got sick, so we couldn't do it. But it's going to say like bouncy ball was dropped from a certain height, and every bounce after the initial bounce is X% of the previous one, right? And you're going to have to fill in a whole table. You're going to have to write an equation. You're going to have to tell me what the, I don't know, like fifth bounce is or something. I don't remember, but that's going to be the problem, right? So think about like the bouncy ball. Gets smaller and smaller. The bounce gets smaller and smaller every time, right? Okay, cool. You okay on that? All right. Huh? What?
You said it goes, I hypothesized until it's halfway. Halfway of the previous bounce.
Yeah, that's what we were going to do, was we were going to count, we were going to calculate the common ratio. But kind of scary. We could like drop it from way up there. I don't know. It's going to be fun, but too bad. Okay, and then number 12 and number 13, again, really similar to problems that you'll see tomorrow. These are like our growth and decay problems. Just like these ones. Just like these ones. Okay? So first thing we want to identify is we just want to read through the problem, and is it growth or is it decay? So number 12 says the cost of manufactured goods is rising at the rate of inflation at about 2.3%. Suppose an item costs $12 today. How much is it going to cost in 5 years? So is this growth or is this decay? Growth. When I need to calculate my growth factor, what did we do? Oops, I was just going to give it away to you. What do I do for growth? How do I find growth factor? How do I find my B? Add it to what? No, not the 12. What do you add to the percentage? 100. So we start with 100 and add the percent. So for this one, my percent is 2.3. So my B, my common ratio, is going to be 100 plus 2.3%, which is 102.3. And then, but that's a percent. How do I change that into a decimal? Yeah, yeah, 1.023, right? Just move it over 2 places. So B is 1.023, right? What's my A? 12, right? My starting amount. And then what do you think I'm going to use for X? 5. How much is it going to cost 5 years from now? So my equation is Y equals 12 times 1.023 to the 5th. So I plug that in, 12 times 1.023 to the 5th, 13.44. So check what you did in there. Make sure you didn't forget that 0. So now that 0 is going to be a big difference. $13.44. Okay. All right. And then 13, population of a town in 2017 is 113,505, and it's decreasing at a rate of 1.2%. What's the population going to be in 2025? Growth or decay? Decay. How do I find my decay factor? What's the difference between my growth factor and my decay factor? Subtract. Minus the percent, right? Subtract the percent. So B equals 100 minus 1.2, which gives me what? 98.8, but that's a percent. So what do I do with that? Move the decimal point. So B is 0.988. And what's A? What's my starting amount? Perfect. And what do you think I'm going to use for X? Perfect. How did you get to 8? Yeah, there's 8 years in between, right? So then my equation is Y equals 113,505 times 0.988 raised to the 8th. What does that give us? Perfect. 103,055. I guess people, but yeah. Cool. Do you guys feel better about your test than you did yesterday? Good. Okay.
Wait, I have a question.
Yeah.
What's the difference between 11 and 13?
So 11 is also decreasing, right? It's still decaying. It's just like a matter of saying like, so rather than saying the stretch is decreasing by 40% each time, in which case we would do 100 minus 40%, which would give us 60% or 0.6. It's just saying that it is 60% of the previous one. It's just like a different way of saying it, which is where these get kind of like, they just get a little confusing and you really gotta kind of pay attention. But does that make sense? Okay. But yeah, the bouncy ball one, you don't have to subtract anything. The percent is the common ratio. But then for these ones down here, we have to like calculate the common ratio. Does that make sense? Cool. Any other questions on this? Okay. All right.